Welcome back to Open Source Summit Japan. And I really hope that you enjoyed the sessions yesterday. And I saw some people tweeted you all went out to dinner last night, so you enjoyed that day even after the sessions, so which is really good. So today we'd like to kick the things off with the Linux kernel panel. Typically, we have when we have the Linux kernel panel, we get a lot of questions from the audience. So if you have any questions, we have a staff holding mics. So if you have any questions, please raise your hand and wait for the microphones to come to you. So with that, I would like to introduce our panel, which include Stephen Rostedt from VMware, Dan William from Intel, and Greg Kroah-Hartman from the Linux Foundation, and our moderator Alice Ferrazzi, Gentoo Kernel Project Leader. So please welcome our panelists.
Okay, someone beat me last time. I forgot who it was that did the selfie. I'm doing the selfie too. Oh, with the real camera.
So, I really start with my name is Ferrazzi, and I'm Gentoo Kernel Project Leader. And I'm also following some of the projects in Gentoo.
I'm Greg Kroah-Hartman from the Linux Foundation. I'm a kernel developer, maintainer of different subsystems and stable kernel pairs.
I'm Steve Rostedt from VMware, and I work on Linux kernel. I'm most known, I guess, for ftrace, the official tracing utility of the Linux kernel. I also am one of the original developers of the preempt.pl patch. I still maintain the stable releases of the preempt.pl patch, and I think my biggest contribution I've ever given to the Linux kernel is the make localmodconfig.
I'm Dan Williams. I work at Intel in their Open Source Technology Center. I'm currently working on persistent memory enabling for Intel.
So, how did you start then to work for the Linux kernel?
I used to write, I was an embedded developer. I wrote firmware for lots of different things. I wrote firmware for printers, for ATM machines, and barcode scanners. And I did USB work for the specification. I had to test my barcodes with all operating systems. Linux didn't really have USB support at the time. My firmware had a bug, and my firmware showed up as a 120 key mouse on Linux. So fixed that up and realized that people were contributing to, I could contribute to Linux in the USB stack. And I started doing that on my spare time, and eventually I got a job.
I used to work for Lockheed Martin back in the 90s, and I did a lot on the AIX systems, Unix. And I knew AIX was dying, and I wanted to go to work on this new thing that's coming out that everyone in the world's using, this thing called Microsoft Windows. And I finally got a project, to work on Microsoft Windows. And I got so frustrated with the development on there because after spending 2 days debugging something, I thought it was the debugger that was broken. And I threw my hands up and screamed, I said some explicitives and said, can't they make a Unix for the PC? And we had this intern sitting next to me, he turned around and said, have you ever heard of Linux? And I went, what? So this is 1996, so I got all the little diskettes and downloaded Slackware and read the licenses. I was blown away by the copyleft license. I was like, this is great, this is awesome. And I'm like, wow, I can actually look at the kernel code. I mean, I've looked at VxWorks and stuff like that and some military stuff, but I got to see like the Linux kernel, like a Unix type operating system from the code side. I'm like, I gotta get into this. And I was going for my master's, and I started looking at doing development in my master's, and then I left Lockheed when this company came up called Timesys, who did real-time development. I'm like, I gotta get a job there because they're working on Linux kernel stuff, so I jumped to that. And eventually I went to I left and became a self-contractor, worked for Siemens Germany in Germany, and then got hired by Red Hat, and now I work for VMware.
I in high school, I got a job as an intern working in the IT department, and somebody there showed me a desktop running with KDE, and the part of what the IT shop was running was deploying software RAID and new storage technologies, and I got to apply my first kernel patch and add RAID to my home Linux kernel on a 2.0 kernel. I thought that was the greatest thing ever, that I can patch a kernel and add new features to it. I was happy at that point.
So thinking about your experience for
How did you get involved?
Yes.
How did you get involved?
I was doing Gentoo Developer for a class for Python, and I was interested about kernel, and because it's more core stuff, and so I decided to move to Gentoo Kernel team, and in the end I became Gentoo Kernel Project Leader. So in your consideration about how you became, you started to become a Linux kernel developer, which skill you think some person need for becoming a Linux kernel developer, for sending much, contributing to a Linux kernel?
Perseverance. No, I'm serious. If you want to work on the Linux kernel, first of all, you have to have that the itch to do something. People come to me and I hate the question, I want to work on Linux kernel, tell me what to work on. No one can tell you what to work on. It's like, tell you what you like to eat. You can't do that. You have to go and look at the Linux kernel and find something that interests you. Because if you're not interested in what you're working on, you're going to lose interest. So you need to really kind of just, look, if you have your laptop and something's not working, you get curiosity. By the way, you can use ftrace, by the way, to trace the functions, and you can actually follow with the code. There's a function graph tracer. Look at that file. That's how I learn new parts of the kernel. I'll find a system call and say, how's the system call? What's this thing do? And I'll just trace like that system call, follow the code, look at the code, and read the comments. And then look, there's documentation, search for the documentation, and you can learn a whole part about that. And that's when you can say, hey, I can add a new feature, or maybe make something work, or send a bug patch. Like everyone kind of got involved was really to say, hey, I saw this code here, and this looks cool. I can look at it, I can modify it, I maybe send a bug fix, and that's how you get hooked, and then slowly work your way up.
That's so persistent.
Yes.
I'd say humility. So I contributed small bug fixes, and I wrote a driver. I was like, here's the perfect driver for this hardware. I sent it in, and I swear, like 5 minutes later, people were like, this is wrong, this is wrong, this is wrong, this is wrong. And I'm like, this is great. Because I learned, and you learn from that, and you learn from your mistakes, and you make it better. But it's only by accepting that your ego's not involved. It's like, yeah, the code's horrible. Let's make it better together. So you learn how to work together with other people, and there's always somebody else will see your problems. And that's the key, is we work together as a community to solve each other's problems and do that. And I know sometimes we'll put code out there that we know is wrong because it just gets the idea going, and you have to go from there. But just give up your ego on your code and be humble about it and learn from it. And that's what if you just keep doing that, it'll be very, very good.
Yeah, I think it's courage to just look at some code and say how hard could it be to modify this, and get yourself in over your head, and finding your way back out. And it kind of goes back to what Greg was saying, is that you can't have, especially in your school or in your place of work, you can't have all the smart people in the world in the same room. But when you're an open source project, you get to work with all the bright minds across the planet, and that's what really got me hooked, was the fact that I can go in, I can struggle, and then smart people can help me out, and that's why I stay in open source, is being able to work with really smart people.
I want to add one thing. It's like, one thing you want to do is, like, if you play with the kernel, break it. Now with virtual machines, you don't have to worry about breaking your hardware. But put up a virtual machine, change the kernel, and see what breaks. Yeah. Learn from that.
It's kind of amazing how how afraid people are of the kernel. It's just software, and so people think that hacking the kernel is something magical, but it's the exact same as any other kind of software.
It's very simple C code. Yeah. I mean, we write code for other people to read it first, so we have to make it very obvious because I want you to fix my bugs. Yeah. And we don't. It isn't tricky except for the scheduler. But generally, it's very simple, very easy code. The hard part is when the hardware is crazy and you have to do dumb things. There's some great comments, like in some of the graphics drivers, like, do this, do it again, please, I hope it's going to work this time. So hardware is crazy, but it's very simple code. So.
And you look at my trace event.
Yeah, no.
Present company exactly.
Yes.
So, how we can attract new developers to the Linux kernel? I know there is the challenge. Kernel challenge. So, which way we can?
And you're retiring that too.
It's shutting down. Yeah, that challenge, I think, is still going, but and you can still get in if you ask nicely. But we have over 100, so we have 250 people per kernel release as a developer. I think about 100 of those are brand new, every release. So we still have a lot of new people coming in. Most of it's dry bugs, so you just do one patch. So that's a good place. But you never know who's going to do that one patch and then get hooked and do more. So a great place to start is I point out the staging part of the kernel tree and driver staging. Just fix a patch that fixes a comment or changes proper grammar or changes the coding style. And that teaches you how to get past the set up your email client, send a patch in, get a response, get it approved. I mean, that takes a little while to just learn that basic process. And after you do that, then you can go on and do other stuff. And that's a great place. We have maintainers of whole subsystems in the kernel that start out in staging. So it's a very good thing to have, and that's why that's there for people to do. So I strongly recommend that. Yeah, the little kernel challenge is a great thing. What do you guys recommend?
Well, actually, it's funny because sometimes it's up to us to help make things go. Like right now, one reason why I got hired at VMware was to help people inside the company become more open source friendly. And one of the things that I have to do is kind of work with people because a lot of times, like those one drive-by patches are companies where you find a bug, send a patch, and forget about it. We're trying to break people from that and say, no, if you're going to start committing to an open source project, stop and become part of the community. Try to get a little more involved. And we're trying to work up with the upper management to say, give the engineers more time to actually spend, because it takes time to work with it. So we're trying to give time for that. I have this project I'm trying to work on to create like an open source project out of like a VMware thing. And actually I went to the university, my university that's nearby, and I talked to my professors, and I said, can you give me some students? I used the term minions, but I guess that's not good. But actually he said he got a PhD student for me who I'm trying to get to work with me to try to also build up a community to get new people, not VMware people, but just anyone to come and work on this project. It's a kernel batch project, and try to get more people involved.
Yeah, the advice I was given when I started was find a bug and fix it, and now we have staging. That's also a good place for people to get started. But I think another place you can have a big impact is writing tests. Like I think any maintainer, if you send them a test case, that they would take it immediately. And even if you find, so maybe you can't find a bug to fix, but if you can find a bug and write a test to trigger that bug and make sure that it never breaks again, that's also valuable. So I think that might be another way to get in, to start out, just trying to see if you can write tests to break things.
Or just run the tests we have. Yes. I mean, we just found nobody had run the LTP test suite on ARM64 in a year. And we found there's bugs in the 4.4 kernel. We ran it on an emulator, but not on real hardware. So nobody was running that test on real hardware. It was just, that blew my mind. So just run the tests we have, please.
And there's also, inside the kernel now, there's tools self-test directory. Please go look at that. Go download the tools self-test directory. We're trying to add a lot of small unit tests with the whole system. I'm working with ftrace. I have a whole test suite outside of Linux that no one else uses. I'm slowly trying to get that involved. It takes time because my test suite is usually, I found a bug, I write a quick hack to simulate that bug, and then I just add it to my regression test. But it's really a nasty hack test, and I don't want to let anyone actually see how bad I can write code. So that's why it's not up there yet.
I also know that Iraq is involved in Google Summer Code, and I think that is also...
Google Summer Code is great. We average, unfortunately, 1 student a year. It's very bad. The last student actually was from here in Japan. He did great work. So we have 2 students, I think, this year maybe for kernel. No, 1. Actually, there's only 1 for kernel again. The outreach program for women is also great. We have a lot of people that apply for, and I think we have 6 people every 6 months. That's a great program too, to get them all.
So, which setup are you using for developing the kernel?
What setup? Well, you'll notice I got a new laptop yesterday, so I'm transferring everything over. It's just, I have whatever laptop I have access to, and I have a test server that from the Linux Foundation I can do test builds with, and Git, so any distro. Well, I use Arch or Gentoo, but yeah. So.
Well, I have, at home I have like 3 or 4 machines that I run almost 24/7 that just does tests, and I have this script called ktest. It's in the kernel directory. If you go to tools, testing, it's ktest.
It's a great.
It's funny because it's kind of what's the word? It's not exactly what it means. Ktest doesn't do any testing itself. And what it does is it basically, you have to set up a way, all you need is to have like an external machine, either a virtual machine or real hardware. You have to be able to read it through standard input and be able to reboot the machine remotely. And then what it will do is it will boot up the machine, it will scan the boot logs to see there's no crashes or anything, and then if you say run this test, it'll actually it'll install a new kernel, it will then send something to the machine, and then it will run it for you. And you can run several tests. That's what I usually do for before I send anything to Linux. I have a 13-hour test suite that comes from ktest. I haven't done make install, or make module, or modules install, whatever it is anymore. I forgot. I don't even know, because I haven't done it in years. But my test thing is, I'll write code. I'm an Emacs person, so I'll write code in Emacs, and then I'll go and say, ktest the machine I want to install it on, and then I go read Facebook and stuff, and then, and then look over, oh, my test is done. Oh, and then I go and see if everything's done. It will actually, take the code I just wrote, it will build it, install it on the machine, and run it, and reboot the machine to my machine. And then when it's all done, I'm like, oh, one thing, I'm trying to get the maintainership off to John Hawley too, because I wanted to email me when it's done.
Oh, I modified it.
Oh, you did do that?
Yeah, that's what I did for stable tests.
Then why did you send a direct?
Around it. Anyway. Oh. So yeah, for stable, all this tests and build on the Linux Foundation server, I submit it using kselftest. It builds them all, and then emails me when I'm done. If there's been any warning or errors. Or something.
I need that inside ktest. What do you do?
So my development workstation is a pretty baby server with a lot of memory, with built kernels on it. But the fun thing about working at Intel is we get access to early hardware, and throwing this booting Linux kernel is like one of the most stressful things you can do to new hardware. And find lots of interesting bugs to go track down. So that's a fun part of my environment is what crazy hardware is going to break today.
I'm using Gentoo.
Have you tested Gentoo kernel patches that you released?
I made automation system for testing such patches that are released for the Gentoo kernel. And now we are using some server for doing such tests. And how the kernel is testing the stable.
How do I test the stable kernels?
You send it to everyone else and say, hey, test it for me, please.
I do.
you test them by releasing them.
That's what users are for.
Sadly, no, actually we got them better. So I test build them. And if they build successfully, Gunter has a test machine in his basement. So there's one guy in California with a machine in his basement that builds all the stable kernels, boots them in a zillion different configurations on QEMU, and sees if they work. And he does about 150 builds, different architectures. The zero-day kernel bot tests it, and kernel CI. Kernel CI is actually really good. They test all the embedded, so I'll get a response back within a day saying 80 machines booted, 2 didn't, and so there's something wrong in there, usually because the power supply broke somewhere. So those get tested, and Sua, the testing maintainer for the kernel, she tests them on her configurations and let me know. But then I release them, and then I get real reports.
Yeah. It's like no matter how well you test it, the best
No,
testing
that's
is.
fine. But actually, so booting a machine is a non-trivial task for a kernel. So usually I get that, but we'll get some like, oh, a week later, something crashed longer, but that's usually rare.
One of the things, one of the gaps in our testing is that we need, people think that we need hardware for testing these things, and one of the new efforts I've been trying to drive to get people to write hardware unit tests using mocking techniques. So if you're interested in writing unit tests for your hardware and run the test without hardware, talk to me afterwards. I'll show you
I
something.
would love that. I would love for that to be, yeah, because for a lot of the hardware I deal with, I have no idea. Well, the graphics guys, don't they have a whole emulated graphics system? They test that like
Right, yeah,
virtual system.
they're starting to like, yeah, look at, in the last kernel, they had like 200 commits adding new unit tests, and they're emulating things and finding a lot of problems earlier.
It's just really
So can you back to my kernel? What do you think is hot into the kernel now?
It's a boring project, nothing's hot.
Just new hardware support all the time. New hardware, lots of new hardware.
Well, eBPF, that seems to be the hot thing. Hey, be able to run like, just-in-time file code inside the kernel.
Well, you get new hardware.
The hottest thing working right now is trying to get file system developers to get on board with what we need to do to optimize for persistent memory. Actually, we've had this discussion about file systems need you to call fsync to tell you that the writes are done, and it's been that way forever, but that's a little bit too slow for this new world where persistent memory is involved. So we're still working through how we can evolve Linux storage for persistent memory.
I guess on the real-time front, the two things that are kind of big is Thomas Leichter is rewriting the way hot plug works. CPU hot plug. Rewriting CPU hot plug, and I'm like constantly test Android. I have a CPU test stress or stress test that basically it just set up a way of it did a binary count, like 0, 1, 1, 0, 1, 1, whatever. And that's enabled and disabled CPUs that way. So what it would do is shut down CPU 0, then it would enable CPU 0, and then shut down CPU 0 and 1, and then it would enable like 0, like it just went up like the binary count with all the CPUs that way. And every single kernel I ran, when I first wrote this, every single kernel I ran on it, I blocked the machine within a few seconds. Every kernel that went down. It's like the CPU hot plug is such it's got a lot of race conditions. So it's really nasty code, and Thomas Leichter is working on rewriting it, doing it in state machine, and making sure that everything is closed. And right now we're finding bugs like crazy that's been there forever. And we're fixing all that, so now CPU hot plug will eventually be strong. The other thing that's on the real-time front too is the SCAD deadline. Hopefully, I did a talk about that yesterday, and hopefully we can change. Peter Zelstra wants to get rid of priorities. He wants priorities to be obsolete and everything to be like a SCAD deadline based system. That'll be interesting accomplishment if we get that far.
But the CPU hot plug thing is an interesting thing because the giant servers that came from, or they used to throw a whole drawer of CPUs in and out, but then the embedded people decided to do power management that way and found all the bugs. And now the real-time people want it for other reasons, and it's going to fix it for everybody.
Well, actually, the reason why we want it has something to do, like we don't want CPU hot plug. It's just that when we get real-time in there, everything has to work. We can't have regressions. We can't add the real-time patch and cause a regression to mainline. The CPU hot plug code, once we add the real-time patch, it breaks it's immediately. It doesn't work anymore. And we have all these hacky workarounds to make it kind of work. And for us to get the real-time patch in there, that's the reason why we have to fix CPU hot plug, is because we add CPU hot, if we add the real-time patch, we break CPU hot plug. And because CPU hot plug is already broken. Real-time patch, one thing about the real-time patch, it finds bugs real quick. So it changes kind of the way the kernel runs. So if you have a bug, you're more likely to trigger it. Actually, the reason why Linux can run on 1,000 CPU machines is because of the real-time patch. We were able to find SMP bugs, because the paradigm of real-time patch, I'm not going to go into the details of it, simulates, so every task is like a CPU. So if you have 100 tasks, you have like 100 CPUs on a single CPU machine. So I remember even Andrew Warren was like, how the heck did you trigger this? You needed like 10 CPUs. This is back when people didn't have 2 CPUs. It's like, it was unheard of. And I said, we ran the real-time patch, and I could trigger it in a couple minutes.
So, the last question from me is, the new release time of stable kernel is becoming so short. How you cope with such short time?
Yeah, so stable kernels, I've been doing about 1 a week for release, and then I do about 3 or 4 kernel releases at the same time.
I handle the stable RT kernels. I got to try to.
You got to keep on that. And so I had 3 days off and traveling here. It's like nothing happening. It's fast. I'm trying to do that because we're averaging about 8 patches a day to the stable kernel. So this is a kernel that's like almost 2 years old. 8 patches a day are.
I do 3 of them. Every responsibility.
Yeah. So I mean, so kernels are. I mean, these stable kernel patches are real. They're fixing real bugs that real people have. We need to do that. So I have it almost automated that I can release them well, get them out there tested, and do that. So I've automated a lot of things, but it's still reviewing the patches and going through them. I need to keep up with all the bugs that are being fixed. So I have to keep up with that. That's why I'm doing about 1 a week. And if I wait 2 weeks and that rate didn't slow down, I just have a bigger one, and I do a release with 200 patches.
Also, Gentoo to automate over your automation.
Yes. Automate. And I have to update the Gentoo vanilla kernel sometimes. Yeah, it's tough. And then we're also merging them into the Android. If you have Android devices, I'm automatically merging them into the Android common trees now, the stable kernels. So that's part of that release process and testing to get out to SoC vendors. So that's a lot of work I've been doing. I've been going around talking to all the SoC vendors, working with Google to try and fix their kernel Android process and how that's working over time. And that's changing a lot with the releases that they're doing this year. So it's just going through and doing that. So yes, it does reduce my time to actually write the code. But all I do as a maintainer, and Dave Miller said this really well years ago, as a maintainer, you're like an editor. You read other people's stuff, and you offer criticism every once in a while. And because you used to be a developer or a writer, you have a little project on your side, but you don't write new code. If you look at the maintainers of subsystems, we're people that read other people's stuff, and we offer comments and direction that way. We're not writing new code all the time. It's very rarely. I have a little tiny patch set of things I'm working on. They trickle out. I've been now picking up one of the kernel hardening options. I do one about 1 new kernel hardening feature release. So I got one last one. I have the one coming out now. That's my little fun things I do. It's a little security patches.
I'm still doing it.
Yeah.
I try to do both, and I sometimes slip on the maintainer side because I'm too busy focusing on something. So I tell people, if you send me a patch and I don't respond to you within a week, it doesn't mean I'm ignoring you. It's just that it kind of got lost. Just send me a ping. You won't offend me if you said, "Hey, did you forget about me?" I'll say, "Yes, I did. Thank you for reminding me."
Yes, that's very important. If you don't get a response in a week or 2, just resend it. We do not feel bad about it. Do not feel bad about doing that. Please just resend it.
And by the way, your release cycle really, because I try to do the kernel real-time stable releases every other week, and every time I do that, I'm like, what the hell, Greg?
And I notice a public thank you for the work you do on stable, because it allows, especially at Intel, when we're trying to develop new hardware and trying to get other teams to test new stuff, I can point them at the latest stable kernels, and they can get on with their hardware testing. And it really helps us in not having to track latest upstream when we get latest fixes. It's a huge. It's one of the benefits of working upstream is that we get this testing spread out across the industry. It's really important.
So I think we're close to the
question.
the audience, questions? Is there a microphone?
Yes.
Yes.
Hi, thank you for your great work. I wanted to ask, why has the Linux kernel never been forked? What's the secret there?
We fork it every,
It is
fork it.
So there's what, 4,500 developers. That's like 4,500 forks, and they all just happen to converge every 8 weeks.
Okay. I can't believe this. A lot of times people always say Linux is a Unix, and they talk about the Unix forks. And the difference really is closed source proprietary software, fork is bad. Open source, community software, forks are good. What happens is in a proprietary environment, you fork a kernel, someone else has changes, new changes, they never merge back. Now you have, as a customer, you have to look at different, which one you want. You say, okay, this has the most features I want. There's no shared features, so you have to pick which is the most features you're going to use the big bad product, and then you have lock-in and everything. It's horrible. Forks will destroy it. That's how Unix died. With Linux and open source society, you could fork. We had forks. It goes back. Alan Cox had his own fork out there for a while because there's a disagreement. Maintainers disagree. They'll fork off to this thing. And what happens is when there's a feature that becomes really good, and you say if there's a fork, now you let the users decide which one's better. And the one that gets the most will then win, and that's the merge will come back. The other guy's like, I'm losing customers because I don't have this feature that the other side of the fork has. So I'll merge it in. So we fork all the time, but we all merge back. So it keeps moving forward. So forks are good.
And every device you make, you end up like, I pick this kernel version, release here, and go off and do my development, and I release a product. Hopefully I get those patches back in so I can do another product and not have to forward port everything. If you look at a lot of SoC vendors, they don't forward port, and they have to start over, and they add their 3 million lines of code to the kernel, and off they go. So those are forks, in a way. Those are all forks off the main branch. But like, we laugh because I have 8 forks on my laptop, right? of the kernel, but different subsystems we maintain. And then we merge back in, and we fork again, and we merge back in. But yes, forks are good.
Proprietary is a fork.
Yes, reason that. And then we've been slowly pulling stuff in there, but that's been forked for what, over a decade?
Yeah.
But the forks kind of force us as an upstream community to keep upstream rolling. Because if there aren't a bunch of new features and new enabling and new optimizations that are always being added, then there's no pull to drink these people that have forked to come back in and get their code upstream. So it's the pace. It's this rocket ship of advancement that's going along that pulls all the forks back in eventually. Android was technically a fork, and now it's back.
Yeah.
Android's all merged in, but there's a few patches. Yeah, did you see our rate of change just went up again? We're going faster again. Yeah. Over 9 patches an hour. Yeah. Insane. I say that every year. It's crazy and scary, but it's going faster.
That's because we got the process has really been perfected.
We're doing well. We have more developers every year, every release, more patches in it.
Any other questions? Actually, so I'll add on to the fork thing because this is something I saw when I was at Red Hat. If you're familiar with live kernel patching, I knew about the live kernel patching. They were developing it for a year at Red Hat. It was called K-patch, and they're waiting until it was all ready before they announced it. And then there's like, well, we got another month before we announced it. Well, then the Suzy came out and said K-graft, and they were way behind the development. They just announced it quicker before they had it. And this is what I love about like the open source. Red Hat really did get it because I remember talking with the manager of K-patch, and when the announcement came, he said, well, we got to announce ours now so people don't think that we're copying or whatever. But they said, I told him, I said, I'm friends, I saw who's managing it, Yuji Kasina was the manager, and I'm friends with him. And she said, could you go talk with them and we're going to work together so we have one solution. We're not going to have a Red Hat solution and a SUSE solution. We'll have one solution inside kernel, because that will help both of us. So when the company gets it, your competitors, so SUSE and Red Hat are big time competitors, but you're working together with your competitor because it will benefit everyone.
Okay, add on one thing about the speed of development. So